some features within our software, which is Vectorworks Landmark, that gives you an idea of the type of thing or feature that you can get within a BIM authoring software. Very quickly, in context, Vectorworks produces two main products, Vectorworks Architect and Vectorworks Landmark. It's not a plugin, it's not an add-on, it is a standalone, dedicated piece of software aimed at landscape architects, urban designers, and anybody working outside the building. My other hat, for those that aren't aware, I'm on the BIM working group for the Landscape Institute, and I lead the subgroup for technical. So I'm going to pick out a couple of projects, but also mainly features, as I say. This is a good example of the landscape architects, McGregor Coxall, who are actually a multidisciplinary company. They are both have an architectural team, and they have a landscape team as well. This is in Parramatta City, which is basically has been sort of subsumed by Sydney. You've probably seen this. I put it up. It's the government construction strategy document. It talks really about, as far as I'm concerned, BIM in one simple diagram, but BIM as 3 in 1. So we have the digital model, typically three-dimensional. It has 2D deliverables, and it has data as a deliverable as well. What you don't see so often is this version of it, which is the landmark or landscape version of it. Exactly the same thing. These are screenshots directly out of Vectorworks. So we have, again, three-dimensional model, a plan view of that. It's exactly the same model, it's just a plan view. So we're showing it in different ways, but it's the same data. And again, a COBE spreadsheet taken out from that model. Example of early conceptual modelling and visualisation. These are what we call massing models. They're not simple extrusions. They actually carry data with them in terms of the building types, number of floors. They can all be reported out. Again, an early stage model. That's a site model with planting areas in there, parking, which I'll show a little bit later, and some water. Again, direct screenshot of that same image, just the plan, the top view of that model. Again, switch to plan view of that. It's still the same model. We're not producing models and drawings. It's all 3 in 1. It's just the fact that the BIM authoring software has the ability to show that information in different ways. It's been interesting to see or to hear sort of about mandate and BIM being client-led, but also very interesting that last presentation to hear about, well, we did it for ourselves. I think there's benefits to be made for yourselves, irrespective of what the client's asking for. Here's an example, again, that same model. Here what we're doing is picking up some slope analysis of the site. We can specify percentages, minimum and maximum slope. We can see that from a visual point of view. You'll see that in a moment. So this is the model feeding back information to me as the designer or the architect. So this is what I consider to be intelligent design. It's not constraining me, it's actually feeding me back with information. I can then change that model, and I can then get, again, visual feedback, because the model essentially is parametric. It's feeding that back to me. Other specific features we have within the software, we have ability to build roads, hardscape areas, and again, these are not architectural slabs. These are landscape slabs, so they have multiple folds to them. We can specify those folds in multiple directions. And there's some of the subtleties that you get between an architectural product and a landscape product, something that's been designed for a landscape architect's workflow. Some more site modelling information here. By the way, here you can see flow arrows. Again, they are intelligent. Software is showing me those. I'm not having to draw those on individually. The software can even visually tell me the slope simply by the length of those as an additional visual feedback, but I can get specific feedback as the angles of that grade as well. And again, a three-dimensional example of site modelling. Somebody mentioned site modelling today in terms of the level of site modelling that you can get out of your design. Just a quick slide about the fact that we can put in details and information in that model as well. Ability to comply with statutory standards. Here's a parametric car park feature. Again, the user has not drawn these lines in, they're provided by the software, so we can feed in the values of that car park space, the minimum maximum values, and it will optimize those parking spaces parametrically. Clash detection or clash avoidance, whichever way you want to look at it. Somebody mentioned here about just doing that from a visual point of view. There are clash detection tools and capabilities, but I think one of the first times I met Duncan, he mentioned the fact that a lot of the clash detection they do is purely by looking at a three-dimensional model, because you can see it in a way much more easily than through two-dimensional drawings. And I think Rob mentioned earlier on in his project when they were doing some 2D drawings and they put the drawings together and the building didn't actually fit. I had exactly the same experience about the same time ago, and that's what convinced me that 3D is the way to go. Zones of visual influence, again from the site model. If that's modelled accurately, you can model the objects accurately, you can set your perspective and your camera in exactly the position you want, looking from a particular direction, you'll see what you get. That's not photoshopped, that's directly out of the software, directly from the camera. So a lot of that has been about sort of what we see as feedback visually. Some information about the data and the I in BIM, the information, and particularly within the supply chain. I think Bill mentioned earlier on in one of the feedback sessions about how the data travels through the supply chain and exactly how you do it. Well, in a talk without showing the software, this was one of the slides I sort of put together, and I see it basically as data in, a receptacle, and data out. Now, depending where you are on the supply chain, it's still, you have to have data coming in, somewhere to store it, and data going back out again. I'm going to work backwards here. We've got Kobe, we've got the software, and then we've got, at the moment, product data templates. So this is a what we call a Kobe pre-flight schedule within Vectorworks Landmark, so we can view what the Kobe information will look like from the Vectorworks model prior to going out. It goes out from Vectorworks as an IFC formatted model. So it comes out from this model as IFC. Here's my IFC data with my Kobe values. And then, as I say, working backwards, here's my product data templates. This information can be attached to that IFC data as custom IFC property data sets. So again, Rob in his previous talk talked about IFC, whilst there aren't a vast range of specific landscape entities, you can tag and create custom property sets, and that's really our next step in terms of the Landscape Institute. Just talk about a side project there in terms of what we're doing with product data templates. I know one of Claire's sort of pet topics, and I think she quite likes the idea of the 48-hour competitions, the BIM competitions. This was, I know Henry and probably other people have been involved in those as well. I think they're a fantastic way of getting involved in BIM if you've never done it before. It's hard work. You do lose a bit of sleep over 48 hours because they are genuinely, that's about roughly the amount of time that you are working non-stop. But this is an example of the recent one in New York. It was based on the Hudson Yards train goods yard, and here we've got the Highline urban park for anyone that's aware of that. I thought this was an interesting example of where sort of architecture and landscape, architects and landscape architects were working in parallel, very close together, and in a short space of time. We also had, at the same time, I'll come on to, there's another slide I'm going to talk about how they're working in parallel. Before that, I just want to talk about some of the things that you can also do with big data. So, New York City, their websites, they provide shapefiles, so GIS information. That comes with metadata, comes with lots of data. If you look at that information as the shapefile in just lines, it's very hard to actually visualize what that information is telling you. What we can do, this is an example where we can take that information, we can take the metadata, and we can assign different colours effectively to it, and we can visualise what that metadata is telling us. So we can see here what the water zones are. It automatically colours up that black and white line drawings. We can see there the emergency services departments and boundaries instantly. Again, this doesn't come across looking like this. It's the metadata that we're interpreting. Here we've got school districts, and here it's New York, so these are hurricane zonings through there. But an example of kind of collaboration, but also how you can use big data. I was talking about some of the collaboration. So this is the site and the buildings. So we've got a skyscraper here, 60-storey, and a outreach community sports centre here. We teamed up with and collaborated with some airflow analysis consultants. Actually, they were students from Japan. 2 minutes, okay, I'm very close to the end. This is what the prevailing wind looked like, and it basically created this turbulence. They suggested that we created added trees and louvres, and this is basically the example of adding those. So that, again, the simple knowledge that that is what is adding to the design. Yes, you're going to put trees in there, but that gives you some additional rationale for doing it. Just a last project. This is called the Green Park. It's actually called the Drying Green. Again, all screenshots from Vectorworks, the model, plan views, sections.